Hello everyone, this is Solved by Hand channel. I hope that you are doing well and that you are ready to watch a new video from Solved by Hand channel. In the video today, we'll continue talking about thermodynamics. So, in this video, we'll see part 2 of chapter summary 1 of thermodynamics. Part 2 of chapter summary 1 is about boundary, systems, and control volumes. So this is thermodynamics chapter summary 1, part 2. In part 2 of this chapter summary 1, we'll talk about boundary, systems, and control volumes. So, without any further delay, let's go to our paper and start moving our pen. Let's go to our paper. So I will start this part 2 with note 1. So I will start with writing note 1. I will start note 1. A system is defined as a quantity of matter or a region in space or a region in space chosen for study. The mass or region outside the system is called the surroundings. So let me first highlight this notes. We have note 1. So in note 1, what do we say? We say that a system is defined as a quantity of matter or a region in a space chosen for study. So this is a definition for a system. A system is defined as a quantity of matter or a region in space chosen for study. Also, we can say that the mass or region outside the system is called the surroundings. The mass or region outside the system is called the surroundings. And here I think that we have two keywords. We have the keyword system. I should highlight this. We have the keyword system. So system, a system, and we have another keyword which is surroundings. Now we can go to Note 2. We can go to note 2. Note 2. The real or imaginary imaginary surface that separates the system from its surroundings is called the boundary. The boundary of a system can be fixed or movable. And let's see this again. Let's see what we wrote in these two sentences. So here we just have said that the real or imaginary surface that separates the system from its surrounding is called the boundary. The real or imaginary surface that separates the system from its surrounding is called the boundary. The real or imaginary surface that separates the system from its surrounding is called the boundary. The boundary of a system can be fixed or movable. And here again, I think that we have few keywords that we have to highlight. So I will highlight the word boundary. So this is the definition of boundary. The real or imaginary surface that separates the system from its surrounding is called the boundary. So this is the first keyword. And I have other keywords. So the boundary of a system can be fixed or movable. Fixed or movable. I will highlight also note 2. Now we can go to note 3. Note 3. In note 3, we can say that the boundary is the contact surface shared by both the system and the surroundings. Mathematically speaking, the boundary has zero thickness, zero thickness. And thus it can neither contain any mass nor occupy any volume in space. So this is said about the boundary. So what we have just said, so we just say that the boundary is the contact surface shared by both the system and the surrounding. So the boundary is the contact surface shared by both the system and the surroundings. Also, we just say that mathematically speaking, the boundary has zero thickness. So mathematically speaking, the boundary has zero thickness, and thus it can neither contain any mass nor occupy any volume in space. So thus it can neither contain any mass nor occupy any volume in space. And to say all this, to see all this, we will see example 1. So we will see example 1. We will see in example 1 an explanation of what we have just seen in note 1, note 2, note 3. So we will see the explanation in these notes. We will see them in example 1. We will see one picture. So let's move to example 1. So this is example 1. Example 1. I will highlight example 1. So in note 1 we spoke about system, we spoke about boundary, and we spoke about surroundings. So we will see this in a picture. So let's suppose that this is our system. So let's suppose that this is our system. So this is my system. So this is my system. It can be any system, it can be gas or anything. So this is my system. Here my system. So this is the system that I am studying in this example. Also my system has a boundary. Here the boundary that I am speaking about is this. This is the boundary. This is my boundary. This is my boundary. This is the boundary of my system. Normally it is on the black line, but just to differentiate between the red and black, the line are a little bit separated, but normally the boundary is the black line or the red line, as you can see. This is my boundary. Also, we spoke in our notes, note 1 and note 2 and note 3, we spoke about surroundings. So here we should see, so what is outside of our system and outside of the boundary is what we call the surroundings. So here, surroundings, it can be here, surroundings can be here. So here, surroundings, here we have the system, inside is the system, and here we have the boundary. So red dashed line, that is our boundary. So this is our boundary. So this is boundary of our system. So, and as we have seen in the notes, so the boundary has zero thickness. The boundary has zero thickness. So this line is not thick, it is very thin. So the boundary has zero thickness. So this is our boundary. So this is the boundary. So this dashed line. So let's continue with our notes. Let's move to another note. Let's move to note 4. Now we'll speak about note 4. So note 4. In note 4 we can say that systems may be considered to be closed or open. Those are very important words, closed and open. So systems may be considered to be closed or open depending on whether fixed mass or a fixed volume in space is chosen for study. So let's see this sentence again. So a system may be considered to be closed or open, dependent on whether dependent on whether a fixed mass or a fixed volume in space is chosen for study. And here we have two keywords that I have to highlight. So the keyword one is closed and keyword number 2 is open. So those are very important words that we should remember: open system and closed system. So let's speak about closed system. So what is a closed system? What is the definition of closed system? So we'll see that in note 5. So let's go to note 5. Note 5 says that a closed system, I will open parentheses, also known as a control mass, so or just a system when the context makes it clear. So a closed system, also known as control mass or just a system when the context makes it clear, consists of a fixed amount of mass and no mass can cross its boundary. That is, no mass can enter or leave a closed system. But energy in the form of heat or work can cross the boundary. So let's try to understand this note. Let's try to understand note 5. So note 5 says that a closed system, also known as control mass or just a system, so we can call it closed system, also we can call it control mass, or also we can call it just a system. When we can call it a system when the context makes it clear. So normally we call it closed system or control mass, and sometimes we can call it system when the context makes it clear. So those are three names: closed system or control mass or a system. There's three names. They distinguish the same thing. Closed system, we can call it closed system, or control mass, or a system when the context makes it clear. So a closed system consists of a fixed amount of mass, and no mass can cross its boundary. So a closed system consists of a fixed amount of mass, and no mass can cross its boundary. That is, no mass can enter or leave a closed system. So that is, no mass can enter or leave a closed system. But energy in the form of heat of work, but energy in the form of heat or work can cross the boundary. So that is the main characteristic of closed system. So the main characteristic of closed system, that mass cannot cross the boundary. The mass cannot cross the boundary of closed system, but energy in the form of heat or work, it can cross the boundary. But mass cannot cross the boundary of closed system. it can't, but only energy in the form of heat or work, energy can cross the boundary. Here I have a few keywords that I should highlight. So I have a keyword closed system, I have another keyword control mass, or a system when the context may clear consists of fixed amount of mass and no mass can cross the boundary. That is, no mass can enter or leave a closed system, but energy in the form of heat or work can cross the boundary. So I will also highlight energy in the form of heat or work can cross the boundary. I will see now I will see we'll talk about note 6. We'll talk about note 6. So now we have note 6. In note 6 we can continue and say that the volume of a closed system does not have to be fixed. Which means that the volume of a closed system does not have to be fixed. It can be variable. If as a special case, even energy is not allowed to cross the boundary, so let's continue. If as a special case even energy is not allowed to cross the boundary, that system is called an isolated system. Here I will highlight note 6, and I will highlight this sentence. So the volume of a closed system doesn't have to be fixed. The volume of a closed system does not have to be fixed. So the volume of a closed system does not have to be fixed. It can be variable. If as a special case even energy is not allowed to cross the boundary, if as a special case even energy is not allowed to cross the boundary, that system is called isolated system. That system is called isolated system. And I will highlight here the word isolated. isolated and system. So this is an isolated system. So if even if as a special case even energy is not allowed to cross the boundary, that system is called an isolated system. And to understand all what we have seen in these notes, so we will see example 2. So we will see example 2. We will see the drawing in example 2, and we will try to understand what is a closed system. So let's see example 2, example number 2, example 2. So this is example 2. So in example 2, let's suppose that we have a cylinder and a piston. So let's suppose that we have like this. I have a cylinder like this, and I have moving inside the cylinder, I have one piston like this. So this is my piston which is moving inside my cylinder. So this is my piston. So here of course it is closed, so the space is very limited here. So this is my piston and this is my cylinder. So this system we can call it a closed system. This is a closed system. This one is closed system. Why it is closed system? But no mass is allowed to enter or to quit or to leave this system. So mass cannot go in or out. So I don't have any holes or from which mass can flow in or flow out. So the mass inside this cylinder, so the mass M is constant. So my mass is constant. Of course, this system, maybe this system, it can be, because we are speaking about cylinder and piston, this system can be gas or air. So it is inside this space. It can be air or gas. So this is my system. My system has a boundary. So the boundary of my system can be this. This is the boundary of my system. So the red dashed line. So this is the boundary of my system. This is the boundary of my system. And we spoke in the notes that we have seen, we spoke about moving boundary and fixed boundary. So of course, so this is the boundary in general. This is my boundary. So this is the boundary of my system. So this is boundary. So this is the boundary. It has no thickness, as we have seen in the previous notes. It has no thickness. It is very thin. So it is very thin mathematically. It is very thin. It has no thickness. So this is my boundary. And we have two types of boundaries here. So in this part of the cylinder is fixed. So this one, because here the cylinder, so this part, so this side of the cylinder is fixed. So we can call this, we can call it fixed boundary. So this is a fixed boundary. And this one, since we have a piston, so we have a piston, it can go down, it can go up, so it can move. So my piston can move up and down. So from here I can call this boundary that I see here, so this one that I see here, so this boundary, this horizontal line that I can see here, this one I can call it moving boundary. This is what this is, a moving boundary. Moving, why? Because my piston is moving, it can move up and down. So also this boundary that I can see, this horizontal line, can move up and down. So this one is moving boundary. Also, this one can be called fixed boundary. This one fixed because this part of the cylinder is fixed. This is a fixed boundary, the same as this one. Also, this one is fixed. So this one also is fixed boundary. Also, this one is fixed. So the only moving boundary that we see here is this one. So this one, this horizontal boundary, is the only moving boundary for our system. So this one is the only moving boundary. Also, since we are speaking about closed system, so in a closed system, we just said that when we have closed system, mass cannot go in or out. So we don't have any mass flow when we are speaking about closed system. So mass cannot go in or out. It can't go in or out. So this is no. So this is not possible. It cannot go in or out. But energy, the opposite is energy. The energy can go in and out. The energy can go in and out, for example. Yes, it can go in and it can go out. So here, if we are speaking about energy, it is possible for energy to go in and out, even if our system is closed. When we speak about closed system, only mass cannot flow in or out, but energy can go in or out. So this is the main characteristic of closed system. Mass cannot go in or out, but energy can go. For energy, the flow of energy is possible. So yes, here it is yes, the flow of energy is possible. So this explains everything about closed system. When we speak about closed system, we have energy can go in and out, but mass cannot go in and out. So the mass of the system is constant, as we have seen. As we can see here, m equal constant. So the mass of the system is constant. So let's continue with another note. We will go to another note. This time that will be note 7. So we'll speak now about note 7. Now in note 6 we spoke about closed system. In note 7 we'll speak about open system. So what is the difference between open system and closed system? So let's speak about an open system. So in note 7 we can say that an open system or a control volume. So we can call it open system or control volume. Those are two names for the same thing. So we can call it open system or control volume. These two names, they mean the same thing. So an open system or a control volume, as it is often called, is a properly selected region in space. It usually encloses a device that involves mass flow such as a compressor, turbine, or nozzle. Flow through these devices is best studied by selecting the region within within the device as the control volume. Both mass and energy can cross the boundary of a control volume. So let's try to understand this. So let's try to understand what we have just seen in note 7. So first of all, I will highlight note 7. And note 7, also in note 7 I have some keywords like open system. I have another keyword, control volume. Also I have keywords mass and energy. So let's try to understand this. So here we say that an open system or a control volume, so we call it open system or control volume as it is often called, so it is often called control volume, is a properly selected region in space. So an open system or control volume is a properly selected region in space. It usually encloses a device that involves mass flow such as a compressor. So it usually contains a device that involves mass flow such as a compressor, turbine, or nozzle. Flow through these devices is best studied by selecting the region within the device as the control volume. So the region within the device as the control volume. Both mass and energy can cross the boundary of control volume. So here, so this is the difference between closed system and open system. So what characterizes open system is that both mass and energy can cross the boundary of control volume. So when we were speaking about closed system, only energy can cross the boundary. So when we were speaking about closed system, only energy can cross the boundary. But when we speak about an open system, in the case of an open system or control volume, mass and also energy can cross the boundary. Mass can cross the boundary, and also energy in the form energy in the form of heat or work can cross the boundary. So this is the difference between open system and closed system. In a closed system, only energy can cross the boundary, but when we speak about open system, energy and also mass can cross the boundary. We will see another note before seeing an example. So we'll try all to understand all this in example. But before moving to the examples, we will see also note 8. So let's move to note 8. So note 8 says that the boundaries of a control volume of a control volume are called a control surface, and they can be real or imaginary. So this is very important. Let's try to understand this. So the boundaries of control volume are called control surface. So the boundaries of control volume, we call them a control surface, and they can be real or imaginary. So the boundaries of control volume, they are called control surface, and they can be real or imaginary. And we will see an example. We will see in example number 3. We will see an example of real boundary and imaginary boundary. We will see that in example. So let's continue with note 8. We can say that in the case of a nozzle, the inner surface of the nozzle forms the real parts of the boundary, and the entrance or the inlet and the entrance and exit areas form the imaginary part, since there are no physical surfaces there. So let's try to understand this before moving to example 3. I think that we have yes. So here we can say that. So the boundaries of a control volume are called a control surface, and they can be real or imaginary. And we will see that in example. We will see the meaning of real boundary and imaginary boundary. We will see that in example. So in the case of a nozzle, the inner surface of the nozzle forms the real part of the boundary. So in the case of a nozzle, if we are speaking about a nozzle, so we'll see what is a nozzle. We'll see that in the example. So in the case of a nozzle, the inner surface of the nozzle forms the real part of the boundary. So the inner surface of the nozzle forms the real part of the boundary, and the entrance and exit are form the imaginary part, and the entrance and exit areas form the imaginary part of the boundary, since there are since there are no physical surfaces there. So since there are no physical surfaces there, so since at the inlet and the outlet of the nozzle there is no material, there is no physical surfaces, so those are imaginary boundaries. So those are the imaginary parts of the boundaries. And we will understand all this in example 3. So in example 3, so we'll see a control volume or an open system. We'll see that, and we understand everything about imaginary boundary and real boundary. So for the moment I will highlight note 8. So this is note 8. Now let's move to our example, which is example 3. So now it's time to see example 3. So this is example 3, in which we will see an example of an open system or control volume. So we have seen the example of closed system. Now in example 3 we will see an example of open system or control volume. So this is example 3. So this is example 3. So in example 3 we have the example of a nozzle. We have what we call a nozzle. So when we speak about a nozzle, so we have a shape like this. So this is what we call a nozzle. So this is a nozzle. So this is a nozzle. So this is a nozzle. This is my nozzle, and I have the boundary of this nozzle. So the boundary of my nozzle, so the boundary is, this is the boundary of my nozzle. So this is the boundary. So this is the boundary of my nozzle. And here what is inside can be flowing gas going in and out of nozzle, or flowing liquid, or whatever. So what is inside, that is my control volume or my open system. So this is what we call open system or control. So this is my control volume or open system. So here we have an example of a nozzle. Nozzle. And in our nozzle we have mass flow. So we have mass flow, we have a mass going in and going out. So mass flow in, and here we have mass flow out. So this is the difference between a closed system and open system. When we have seen the example of closed system, it was not possible for mass to flow in or what. So the mass or inside the system was constant. It was not possible for the mass to flow in or out. But when we speak about control volume or open system, it is possible for mass to flow in and out. So this is the difference between open system and closed system. Also, in terms of boundaries, here in this control volume or in this open system, we have real boundary and we have imaginary boundary. So this one we call it real boundary. Why it is real? Because here we have a physical surface. So here we have physical surface. Here this side is real boundary. Also in this side the boundary is real. We have a physical surface. We have this physical surface or this part of the nozzle. So we have the wall, or if you want to call it the wall of the nozzle. So here we have another part which is physical surface or physical wall of the nozzle. So this one is real boundary. So here we have real boundary. Also here we have real boundary. But here we have imaginary boundaries. Here the boundary that we see here, it is just imaginary. We have just imagined this boundary. There is no material here. There is no surface. There is no wall of the nozzle. There is no material. There is no wall. There is nothing here. It is just a boundary that we have just imagined. So because of it, we call it imaginary boundary. And in the same way, I will call the boundary that I will see here, so that I see here, what I call the boundary that I see here, is it real or imaginary? Is it real or imaginary? Of course, here I don't see any surface, I don't see any material, I don't see any physical surface, I don't see any wall belonging to my nozzle. So this line here is imaginary. So I have just imagined this line. That I can see here, and because of that I can say that the boundary that I can see here is in imaginary boundary. So here in the same way, the boundary is imaginary boundary. So this was about example 3. Now let's move to another. Let's move to note 9. We have seen note 8. Now we'll speak about note 9. So let's move to note 9. Note 9 says a control volume. A control volume can be fixed in size. It can be fixed in size and shape as in the case of a nozzle, or it may involve a moving boundary. So here we just say that a control volume can be fixed in size and shape. So it can be fixed in size and shape as in the case of nozzle, or it may involve a moving boundary. So those are the two cases that we can have. So a control volume can be fixed in size and shape as in the case of a nozzle, or it may involve a moving boundary, and we'll see an example of that in example 4. So in example 4 we'll see a moving boundary. So let's continue with note 9. Most control volumes, however, have fixed boundaries and thus do not involve any moving boundaries. I will explain this sentence. So most control volumes, however, have a fixed boundaries and thus do not have any movement. So in most cases, most control volumes, however, have fixed boundaries and thus do not involve any movement boundaries. So most control volumes have fixed boundaries and they do not have any movement boundaries. So in most cases we find fixed boundaries, not moving boundaries, but in some cases we can find moving boundaries. I will continue and I say that a control volume can also involve height and work interactions just as a closed system. In addition, to mass interaction. So let's try to explain this before moving to the example. So in this sentence we say that a control volume can also involve height and work. A control volume can also involve height and work interactions just as closed system, in addition to mass interaction. So when we have a control volume, so we can have height interaction, we can have work interaction, and we can have mass interaction. So those are the characteristics of a control volume. In a control volume we can have height interaction as well as work interaction and mass interaction. Now we'll see example 4. This is our final example in which we'll try to understand all this. Now we'll move to example 4. So this is example 4. So this is example 4. example 4. So this is example 4. So here in example 4, here again we will see a control volume, and we will try to understand what is a moving boundary and what is a fixed boundary. So we'll try to understand what is a moving boundary. So here in example 4 we'll see a control volume or an open system, and we'll consider again the example of a piston and a cylinder. So again we'll consider that we have a cylinder like this. So we have a vertical cylinder. Inside this cylinder there is a piston. So a piston like this, which can be moving up and down. So this is my piston. So this is my piston. It can be like this. So this is my piston, and I have a control volume. So the control volume that I am considering is what is inside my piston, and so I did a mistake here. So normally my piston is open from here. So from here it is open. I will draw this again. So this is example 4, because here we are speaking about a control volume, we are speaking an open system. So my cylinder shouldn't be closing. So I will draw my cylinder like this. So this is my cylinder, it is like this. So this is my cylinder. I have an opening here, so something, gas or air, can go in and out, and I have my piston here. It can go up and down. This is my piston. This is my piston. So this is my piston, and I have a control volume. So a control volume. So this is my control volume, or my open system. So this is my open system. It is here. Of course my open system has boundaries, so I have to draw the boundaries of my system. So these are the boundaries of my system. So those are the boundaries of my open system, or those are the boundaries of my control volume. Those are the boundaries. So I have a piston, I have a cylinder, I have my piston can go up and down, and I have boundaries, and I have flow of mass can go in and out. So here I can have mass in or out. I can have mass flow in or out. So here, and I have my boundaries. So this boundary that we can see here, so this is, since here this part of the cylinder is not moving, it is fixed. So this part of the cylinder is fixed. So this part of the boundary I can call it fixed boundary. But this part of the boundary is moving, since this boundary is moving with the piston. So when my piston moves up, this boundary moves up. When my piston moves down, this boundary moves down. So this is a moving boundary. So the dashed line that I see horizontally here, this is what we call a moving boundary. So this one is moving boundary. Also, so we have seen in the notes, we spoke about fixed boundary, we speak about moving boundary, and also we spoke about real boundary and imaginary boundary. So here again we have, so this boundary, so it is real, since here we have material, we have the wall, or we have the physical wall of the cylinder. So here the wall of the cylinder, so this part, in this part there is material, so this part is physical, so this boundary we can call it real boundary. So this boundary that I see, that's the vertical line, that I see, I can call it real boundary. But the opposite is this one, so this line that I see here, so this line that I see here, it is just imaginary. So this line that I see here, so here, so from here, so this side, so this line from here to here, to here, so this part of the boundary, so from here to here, it is just imaginary. So this is an imaginary boundary. So this one is imaginary boundary. Why it is imaginary boundary? Why this part is imaginary? It is imaginary, but because there is no physical material here, there is no material here, so there is no material, there is no wall of the cylinder, there is no tank here, so we have just a pipe that leads air or gas in and out, and here in the diameter of the pipe, so inside the pipe there is no tank. So I don't have any wall or any tank, I don't have any material here. So because of that, so the line that I draw here, it is just imaginary. So this is what we call an imaginary boundary. So this from here to here to here to here, so this is just what we call in imaginary boundaries, because the opposite is this one. Here there is material, here there is the wall, here, so all these ones are real boundaries, but here I don't have any material here. So this is what we call imaginary boundary, no material here, so it is not physical, so it is just something that I have imagined. So because of that we call this an imaginary boundary. Also, we have said that when we have a control volume, mass can flow in and out, and also energy in the form of heat and work can go in and out. For example, this is how we have in a control volume or an open system. So mass can go in and out to my cylinder, and also energy in the form of heat. For example, if I put here a flame, so for example a flame here, so if I put flame here, so energy in the form of heat can go. So for example, I can have Q in, so I can have energy in the form of heat can go to my system. So also work can go in or out, so the piston is moving up and down, so work can go to my system, so more work can be exchanged to my system. So in conclusion, we have said that open closed system can exchange only energy with the surrounding. It can exchange only heat and work. But when we speak about open system can exchange heat and work plus mass. So this is the main characteristic of an open system. The main characteristic of an open or control volume, an open system or control volume, that it can exchange mass with the surrounding. It can exchange mass. So when we are speaking about a control volume or an open system, we always find that mass can flow in and out to the system. So that is the main characteristic of an open system or control volume. Whenever you see an open system or control volume, you can find that mass can go in and out. But when you have a closed system, mass cannot go in and out. When you have a closed system, mass cannot go in. So this is different. So this one is this one is an open system or a control volume. Mass cannot can go in and out. It is possible for the mass to flow in and out. So, but when we speak about a closed system as we have seen, mass cannot go in and out. When we speak about a closed system, it is not possible to go in or out. There is no inlet or outlet for the mass. So you can see here that the cylinder is closed, so mass has no way to go in or out. So it is not possible for the mass to go in or out. But energy, yes, it can. For example, I can put here, again, I can put here a flame, and I can have heat. So I can have Q in form of heat. It can go this way. Also, I can have work that can, so since my piston is moving up and down, up and down, so I can exchange work with my system. I can have work in or work out. So this is the difference between a closed system and an open system. So this example finishes part 2 of chapter summary 1. So this example finishes part 2 of chapter summary 1. So if you have liked the video of today and want to support Solved by Hand channel, click on subscribe button here. So you can go here and click on subscribe. You can click on subscribe button here. After subscribing to Solved by Hand channel, you will start receiving notification whenever a new video is published by Solved by Hand channel. Also, you can like the channel by clicking on the like button here. So you can go here and click on like. So you can click on this hand here and you can click on like, and you can like the button here. If you want to share this video on the social media, you can click on the share button here. So you can click on the share button. So you can click here on share, and you can share the video or on the video on WhatsApp, on Facebook and X, and on other social media, as well as on LinkedIn. Whether you like or dislike the video, leave me a comment. You can go here and write your comment, and I will be very happy to hear about what you think about what you think of my videos. So you can go here, so, and you can leave a comment. So you can here, you can write your comment here. You can leave me a comment, and I will be happy to hear about what you think of my videos. Just leave any comment, good or bad. And lastly, I want to show you that there is a second way to subscribe to Solved by Hand channel. You can click on the watermark that you can see here at the right lower corner of the screen. So you can see whenever you open one of my videos, you can see this watermark. So you can click on subscribe here directly, or you can click on the watermark and you will see another page like this one, and you can click on subscribe here. So that's all for today. Take care and see you next time in another video of Solved by Hanshana. Goodbye and bye bye.